Hi, I am Anastasia from Harmony Science Academy, North Austin, and this is my chemistry project on how like bonds dissolve in other similar bonds, and how temperature affects solubility. For the first part of the experiment, I mixed sugar, which is polar, into water, which is also polar, and olive oil, which is nonpolar.
The sugar dissolved right into the water, and in the actual experiment it required much more to be put in before none would dissolve. But in the olive oil, absolutely none of it dissolved. It all just gathered at the bottom here.
The same happened when dissolving salt, an ionic material, into the water and the olive oil. However, when I put the paraffin, a nonpolar compound, into both the water and the olive oil, the opposite happened.
As you can see, the paraffin dissolved completely in the olive oil, but there's still a solid layer of it on top of the water.
When I repeated this experiment with added heat, even more dissolved than before, while the opposite occurred when I was exposed to cold. So why does all of this happen? As it says in the title, all of this happens because like bonds dissolve into like bonds. Bonds that are the same dissolve in one another and won't dissolve in another bond. Polar and polar, nonpolar and nonpolar, as well as ionic and ionic or polar, are soluble in one another. Such as in this picture, vinegar, an ionic compound, dissolves in water, a polar compound, while the vinegar doesn't dissolve into oil, a nonpolar substance. In my experiment, I used polar covalent, nonpolar covalent, and ionic bonds. The salt was ionic, the sugar was polar, and the paraffin was nonpolar. For the actual liquids, I used polar water and nonpolar olive oil. Because of the way these bonds form, they can only form with similarly structured atoms. For my English component for this project, I conducted an interview with Dr. Hans Weger, whose PhD is in nuclear engineering and whose doctoral dissertation was the solubility and speciation of plutonium-6 with phosphate.
The atoms in a polar molecule are arranged in a manner that one side of the molecule has a net positive charge and the other side has a net negative charge. The electrons are shared in a way that the -1 charge and the +1 charge do not fully cancel each other out. For example, water has a slight negative charge at the oxygen atom and a slight positive charge at the two hydrogen atoms. The negative side of a polar atom is attracted to the positive side of another polar atom, thus increasing its solubility. If the solid is not attracted to the dissolving liquid, it will not dissolve. Nonpolar molecules do not have a slight or partial negative and partial positive charge, so the polar molecules do not dissolve into nonpolar solutions. However, nonpolar substances will dissolve in nonpolar liquids because they are similar in structure.
For the temperature aspect, when the solution was heated, the particles moved more rapidly, therefore allowing more to dissolve. For my social studies component, I tried to find out more about who discovered these principles of solubility, as well as the different types of bonds. While the discovery of solubility is uncredited, the people who discovered the different types of bonds are not. The ionic bond was discovered by Svante Arrhenius. He said that bases, acids, and salts became ions when dissolved in water. The covalent bond was discovered by Gilbert Lewis. He suggested a theory that said that atoms share pairs of electrons and used this to create the Lewis structures. The idea was taken and later became the definition of a covalent bond. Solubility is not a new concept. It is used in everyday life, whether we are aware of it or not, such as in making chocolate milk from powder, or using soap to make oil on your hands soluble with water to wash them. There is no major impact of this project, as everything I learned in this project has already been proven and implemented into people's lives. However, this project did give some understanding into a topic that I knew nothing about, and if people knew what I learned, they could know why things dissolve the way they do, and possibly enhance their everyday life by improving any procedure where dissolving something is necessary.